Let's explore further using a statistical tool called Stats.blue. This video is all about regression. We are going to take and compare the value of Excel and Stat.blue. This is the data set we have. For example, weight gain versus calorie consumed. And the formula is straightforward. Let me quickly do it. For example, the correlation, the scatter gives the correlation. So the formula is correl. And then you can take the y, comma, x. So it has given that value. That means 97 is strong correlation. Okay. Similarly, the same thing if you do that regression, which is r square. So you can take this value, comma, this value, and then close it. 94. In other words, if you square these up, you will get the same value, right? So whether regression this value and r square value is same. Okay. In other words, scatter gives that 97%, regression gives 94%. We expect to get 94%, right? That means a strong correlation. Let's see what stat.blue says. So you can go back to that one and click on simple linear and the variable name we have. So I'm just copying this variable name. Weight gain is the response, that is output, and calorie consumed is an input. And let's copy down that value. Calorie consumed is an input, that is called explanatory, and then you have another value is weight gain. Just copy paste this value here, and then include regression one is required. Regression inference is also required. Like it gives further more detail also as well. And let's say we need a significance level. 95% is fine. Alpha risk is 5%. We also have an options, various options. So 95 looks to be good. And let me keep it 4 decimal. Give OK. And it has within few seconds it's calculated that weight gain is strong correlated. And you can see that correlation by 96.97, right? So exactly the same thing we have got here also as well, right? Exactly the same value, 94.03 got the same. And then you also have got the residual value, histogram, normality plot, and box plot. And also it has given this particular value, regression equation, degree of freedom, estimate of slope, standard one, all that it has given. And also it has given the interpretation and reject the null hypothesis because the p-value is also 0, right? So that means significant. Reject the null hypothesis. That means it's a strong correlator, right?